This is Geometry Lesson 10.1, Geometry of Solids. So we are going to start this chapter out doing a whole bunch of definitions. The first definition I have here is volume. Okay, so volume is the amount of space inside a solid. And when I say a solid, what I'm really talking about is 3D shapes. Okay, so we're not talking about plane shapes anymore. We're not staying flat on the surface. We're coming up into the third dimension. Polyhedron, that's kind of the really mathy word for a 3D shape or a solid. It's going to be a solid formed by connecting polygons. Okay, and we're going to name our polyhedra just like we name our polygons, right? So we have a 6-sided polyhedron, that would be a hexahedron. Or we have a 10-sided polyhedron, that would be a decahedron. The only one that's kind of weird is a 4-sided polyhedron. We don't say quadra, like we don't say quadrilateral, we don't say quadragon, we say tetrahedron, so that's kind of weird, but I don't think that's going to be on the test anywhere. Don't worry about the classification of our polyhedra. Face, edge, and vertex for the next three, I'm going to kind of use the same image here. So I'm going to draw a pretty basic solid shape. I'm going to try to add some background dots, make him look a little three-dimensional, okay? So that would be what maybe we'd look at and say, oh, that's a cube, right? That's a 3D shape. And when we talk about the face of the cube, the face is like this flat surface here. So it's actually the polygon, the two-dimensional polygon that is being connected to make the overall shape. So I'm going to say 2D. I'm going to say flat surface. Flat surface. And I'm going to say like the polygon. All those words kind of go together to call what that is. The 2D face, the flat surface, the polygon that is used to form the polyhedron. Same reference image for edge. And so now, and again, I'm going to try to make him look 3D-ish. We're talking about this right here being the edge. So it's a one-dimensional, it's a segment where the polygons meet. Okay. And one more, same reference image. I got that cube again, that 3D shape. And the vertex would be right here. It's like the corner. So technically that's 0 dimension because it's a point. And it's the point where the edges meet. Sorry, my board keeps moving on me. It's hard to write. Okay, so this works with all polyhedra, right? Not just the cubes, but any flat surface is a face. Any segment where the edges, where the faces meet, that's an edge. And any point where the edges meet, that's a vertex. The next two kind of go together, prism and pyramid. So with prisms, we're going to have actually two parallel bases, okay? Two parallel bases. I'm getting frustrated with my board, sorry. So that's where we would have the ones that I kept drawing, right? Those were prisms because I had a square on the top and a square on the bottom. Those were my parallel bases. Versus a prism is going to be a solid with one base. And instead of having a top base, it's going to have a vertex. It's going to be basically pointy. Okay, it only has one base, and then it's going to be pointy on top. So I'm going to draw the same shape here to recognize that it's going to be flat on the top and the bottom. And I'm going to draw the same base here on the bottom, but instead of a parallel base on the top, he's going to be kind of pointy. Sorry, I didn't 3D him too well, but we'll just say he's see-through, right? So we have our flat parallel top and bottom versus we have our bottom with a pointy on top. What we should recognize too is that prisms have rectangle on the sides, right? I don't want to use this word yet because we're going to do lateral face coming up, but rectangle sides versus the pyramids all have triangular sides. And you can have different bases. I'm drawing all of mine as square bases or rectangular bases, but you could have hexagonal bases, you could have dodecagon bases, any polygon on the base. If it has a congruent polygon up top, that's a prism. If it has a pointy up top, that's a pyramid. Okay, so base is what we're going to call those, that's how we name our shape. So that's the bottom, but also the top on prisms, because they're going to have two of them, right, of the shape, versus the lateral face, that's going to be the sides. And I think I'm going to clarify that this is the bottom or top polygon, and it's used to name. Versus this is the sides, and again, we have triangular sides on our pyramids and rectangular sides on our prisms. Altitude is basically how tall the shape is. I'm sorry, that's height. Altitude, yeah, let's go with that. Okay, how tall the solid is. Height, I think we're going to just say the same thing. I think altitude is more like when you have your shape, it's going to be the segment itself, versus height is the number that would go there. Okay. Cone, that's going to look like this. I'm going to not 3D him the best, but it's kind of like a pyramid because he's pointy on top, but he's not a pyramid because pyramids do have to have polygonal bases, and this one has a circular base. Okay, so kind of like a pyramid because he's pointy on top, but because he has a circular base, he doesn't. So circle base, pointy top. Okay. Cylinder is like a prism because it does have two parallel bases, a top and a bottom, right? But unlike a polygon, a polyhedron, it does have circular bases again. So it's going to not be qualified as a prism, not be qualified as a polyhedra. Let's add two circle bases. And a sphere would look something like that. Okay, so it's a 3D shape again, and I'm going to just call it a ball. The technical definition is all points equidistant to a given point in space, right? Because we have that center point, and then we have all the points going around this way, going around this way. That would be equal distance from that point. But as long as we recognize that it's basically like your classic basketball, soccer ball shape, that's all we need, okay? Axis, let's go with on our sphere. This could be on a cylinder too, or a cone too. It's just going to be kind of like the diameter on the circle is the axis on the sphere. Versus a great circle, I'm going to do that same shape again. That's going to be this circle in the middle here. So the largest circle, plane shape in the sphere. Okay, and I think I only got 2 more at the bottom here, and that is the word right and the word oblique. We've seen right a lot in math, right? We talk about a right angle, that's a 90-degree angle, but when we're talking about a right solid, that kind of just basically means it's going to be standing straight up and down. So I'll go with a cylinder again. That is a right cylinder. And when I drew my prism, I was also drawing right prisms, okay? And basically what we're looking for is that the altitude here and the radius on the base here, they are going to be perpendicular. And it's the same here. The altitude here and the segment on the base here, they are going to be perpendicular, okay? So it's a 90-degree angle between the height and the base. Contrasting that to oblique, I'm going to use a very unmathy word. I'm going to say slanty. Okay, so we have our cylinder where our bases are no longer in line at a 90-degree angle. They're kind of going off to the side like that. And I don't know if my art skills are good enough to draw a slanty prism, so I'm going to just leave it at that. Maybe I could do a slanty cone. That would be easier. I think the cones are easier to draw, right? Slanty cone. It's not going to be straight up and down. The angle formed with this altitude here and the base here is not 90 degrees, okay? And I think I'm going to call that it for this video. Good luck on the exercises, and please let me know if you have any questions.